Our lesson for today will be looking at chemistry 1502. We are still busy with alkyne reactions. We'll be looking at halogenation. Lesson 103. Let us start. The reactions we have in alkyne is more or less the same as the reactions we have in alkenes. So the halogenation, we simply add halogens, but in alkynes you should understand that the types of halogens that we normally use is bromine and chlorine. So X represents bromine and chlorine. And another thing that you should know is that when you talk about 1 mole, it's the same as 1 equivalence. So sometimes you might see the word 1 equivalence instead of 1 mole. And then the general equation is that when you take an alkyne and then we halogenate it using 1 mole of X, can be 1 mole of bromine or chlorine, or we can say 1 equivalence of bromine or chlorine, we are going to get a dihaloalkane. Dihaloalkene, I meant, not alkane. This simply means that we have 1 Br or chlorine, I mean this 1 mole. Let us look at the general equation. Suppose we have an internal alkyne, and then we react this with 1 equivalence of X, can be chlorine or bromine. You should know that we are going to get a mixture of cis and trans, dihaloalkene. The reason why we say it's dihalo, it simply means that we have 2 halogens. It's a trans and cis, but you should know that the major product is the trans. Sometimes you might see that the minor product, it is not represented. Don't be surprised when you only see this. This is a major product. Sometimes 2 mole, it will be represented 2 mole or 2 equivalents or 2x2. You can see that we have a total of 4 halogens here. So what happens if we put 2 equivalents? You can see that we are going to have a tetra haloalkene, meaning that we are going to have 4x. Let us look at the examples. Let's say we have this alkene. We halogenate it using 1 equivalence of Cl2. So these are the carbons which are involved in the triple bond. So what will happen is that we're going to have those carbons with our double bonds. Then we are going to have we put Cl here and Cl here. So this part is this one, then we have this part. This should actually be the major product. Let's look at an example whereby we have 2 equivalents. Suppose we have this, and then we have 2 moles of Br2. These are the carbons. Remember that this is the same as 2Br2. We actually have 4 of them. So this carbon initially did not have any hydrogens. So we continue to write what we had here, but we are going to add our bromine atoms here. As you can see, this is a tetra halo alkane. There's no double bond. Let us look at the third one. The third one, let's say we have a ring, and then we have 2 equivalents of chlorine. This carbon and this one, they are involved in the double bond, the triple bond. Going forward, we are going to have something like this, whereby we have our chlorine here, chlorine here, and here. If let's say the very same example, these are the carbons, we have 1 equivalence of bromine. The product would be like this. Should be a trans. Then we have a double bond here. Suppose we have this, we react it with 2Cl2, that is 2 equivalents. Then we are going to have CH3, CH2, 3, then we have our Cl. Our Cl will actually be in this, so we can simply put, the triple bond is no longer there, we put Cl, 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 and Cl. Suppose the very same example, we had one equivalence. We are going to have, these are the carbons which are involved. A trans. I hope you can see how we come about finding the product of halogenation. And one thing you should know is that when we have 1 equivalence, we undergo anti-addition, meaning that we don't add it on the same side. Since you can see that our major products are trans, it doesn't matter what type of an alkyne you have, the procedure is the same. That's it for this lesson video. This is Paula SJ. Thank you very much.